We can also perform a stratified analysis. Let's take a look at an example here. In this case, we want to stratify on treatment group. In order to do that, we simply add the statement strata and then the name of the variable, in this case is treat. This will allow us to compare the two survival curves for the two different treatments. Once we run the code, we will see this type of output. In this case, we will see an output for each of the two treatments. In this case, is treatment equal 1. This shows the total number of lines, which is the number of patients plus 1. In this case, it's 13 lines because there were 12 patients. Two patients failed at day 8. An additional patient failed at day 52, 2 more failed at day 63, and then another at day 220. So these were a total of 6 patients. The remaining 6 were censored at different times, as you can see that from the asterisk. What's the probability of surviving at least 8 days? This is 83.3%. The probability of surviving at least 220 days is 50%. This is also the same probability of surviving 365 days or more. Here we can see the survival function. Because we have stratified by the two treatments, we will see two different curves, one for each treatment. Treatment 1 is in blue. We will see that after 220 days, there were no more deaths. So we have a straight line at 50%. Treatment 2 is shown in red, and you can see that there were continuous deaths all the way for several days after day 220. Let's take a look at a closer view. What was the median survival time? Well, for treatment 1 in blue, it is difficult to define because we have a straight line at 50%. The last death occurred at 220 days. For treatment 2 in red, we can see the approximate median survival time in the picture. This seems to be at around 200 days. We can confirm that looking at the log. We can see that for treatment 1 in blue, we cannot define the median survival time. For treatment 2 in red, the median survival time is 195 days. We can also compare the two survival curves. We can think about two methods. We have a log rank test and the modified Wilcoxon test. The log rank test is typically the test that you would most likely see reported. This is similar to the Mentor-Hansel test, and some authors refer to it as the Cox-Mentor test. This test is more sensitive to differences later in time. On the other hand, the Prentice modified Wilcoxon test is more powerful to detect differences early in time. And because we typically are interested in a long-term prognosis, then we typically are interested in the log-rank test and in differences later in time. And we can find these two tests in the output. The first one is the log-rank test, and the second is the modified Wilcoxon test. And you can see that the p-value is slightly different. Both of them show that there is no real difference between the two treatments. However, keep in mind that we have a very small sample size. We can also look at whether there was differential attrition or loss to follow-up between the two treatments. For treatment 1, 50% were censored, whereas for treatment 2, only 15% were censored. So there was differential follow-up, differential attrition in the two groups.